Hello all. In this session, let us go a bit forward from the discussion what we had in the previous session in instruction cycle. In the instruction cycle, we started designing the registers because registers are the key elements to hold the instructions and associated data elements. We designed the single accumulator organization registers, right? In which we have already understood the purpose of each and every register, such as program counter holds the address part of the next instruction and the address register holds the addresses that are needed to be located within the main memory. Now let us understand the sizes of each and every register. For that, we need to understand the size of the main memory initially. Let us say I do have a memory unit which is of 4096 words as it is shown in the picture. That is, my main memory unit is of 4096 words with a data size which is equal to 16. What is this data size? What is this 4096 word size of main memory? My main memory unit, let me draw it here, is designed with a size of 4096. Total locations within the main memory are equal to 4096. With each location has a size of 16 bits, right? So now let us talk about a register size. Why we discussing right now about this memory size and the register sizes? Because the programs and the instructions are residing within the main memory. Every time you execute an instruction, that instruction has to be sent from one location of the main memory to one of the registers. So the sizes of registers and main memory does really matter here. One main memory location size is equal to 16 bits, as I told you. So each and every register size should also be equal to 16 digits. There is no doubt about this. In the previous session, we have designed a few registers. Each and every register is of some size, right? The question is, what is the size of each and every register? Generally, all the register sizes will be equal to 16 digits. Why it must be equal to 16 digits? Because one main memory location is equal to 16 bit, and the data that is going to be held by the register is actually the data that is present in any location. So memory word size must be equal to the size of the register. So most of the register size will always be equal to 16 bit, as in the one location size. But some registers are of different sizes. Why? Let us have a look at. As the main memory size is equal to 4096, the address of the main memory will be of 12 digits. That is, this is my main memory, whatever. The size of the main memory is equal to 4096. You also know that each and every location must be represented by its respective address, right? The address part of the main memory should be equal to 12 digits. Why? Because 4096 is equal to 2 power 12. Okay, so the first location address will be equal to 12 zeros, 1 2 3 4 5 6 7 8 9 10 11 12 zeros. Final location address will be 12 ones. So the total main memory will be addressed in between 12 zeros to 12 ones. Once again, the size of the main memory is equal to 4096. 4096, in order to represent 4096 in binary, I do require 12 digits. So the first location will start from 12 zeros, final location will end up with 12 ones. So one location's address will be equal to 12 digits. Okay, so now if you can actually have a look at the registers, some of the registers will only hold addresses, right? Let us say there is program counter. Program counter holds an address, and there is an address register. Address register also holds an address, right? Program counter holds the address part of the next instruction, and the address register is going to hold the address, any address that is needed to communicate with the main memory. So these two registers are essentially hold the addresses. So these two registers will take the length of an address. That's it. the size of the registers will be equal to length of one address in the main memory. So program counter should be equal to 12 digits, and the address register should also be equal to 12 digits. So let us have a look at the size of each and every register. Here, program counter is equal to 12 digits because it holds an address, and the address size is equal to 12 digits. Address register should also be equal to 12 digits because it also holds a memory address. Instruction register, as it is going to hold the instruction, this is 16 digit. Instruction is inside the location of the main memory. Instruction will not be at the address part. Let us say there is a 23rd address. In 23rd address, let us say there is an instruction. Instruction is available in the word part. The word part is equal to 16 digit. Data register. Of course, data register is also equal to 16 digits because data item or operand, whatever it might be, it also will be available in the word portion of the main memory. So the word portion is equal to 16 bits. One word of the main memory is equal to 16 digits. So all the registers that are going to contain the word portions will be of 16 digits. So the instruction, I'm going to fetch it from the word portion. So definitely the instruction size will be equal to 16. Data register size will also be equal to 16. Accumulator, of course, it holds one data word, which is also equal to 16 bits. Temporary register holds an element, data element, which is equal to 16 digit. Input register and output register are just of 8-bit size. Sir, what is this 8-bit size? You know that the input register and output register are used to communicate with the peripheral devices, right? And the peripheral devices are based on ASCII formats. In our data representation, we discussed about the ASCII codes. The ASCII codes are of just 7-bit values. What is an ASCII value? The value of ASCII, let us say you have A is corresponding ASCII character is 65. Similarly, B is 66. So the ASCII characters are from 0 to 127. Then the number of digits that are needed to represent any ASCII character will be equal to 7, because 127, 0 to 127 is equal to actually 128. So 128 is equal to 2 power 7. Okay. So the input register and output register should only be equal to 8 digits because there is no 7-digit format in the computer system. Once again, the size of the input register and size of the output register must be equal to the size of an ASCII character, because by using these two registers, a communication with the peripheral devices will be established. Only ASCII characters will be sent and received through the input register and output register. One ASCII character size is equal to 7 digit, but there is no 7-digit format in the computer system. Even if you want to store the 7-digit, you need to take a complete 8-bit register, because the smallest storage within the computer system is 1 byte. Anything less than 1 byte, it is not possible to accommodate or store. So what we do is, we will take one complete byte size register to store this 7-bit value. Okay. At that time, one digit will be unused in both input register and output register. That bit we can use for some special and additional purposes. So once again, program counter 12 digits, address register 12 digits, instruction register 16 digits, data register 16 digits, accumulator is of 16 digits, temporary register is of 16 digits, and input register is of 8 bits, and output register is also of 8 bits. In which, let us have a look at which are the register that are going to hold the data part, rather, the word part of the main memory. Instruction register is going to hold the word part. Data register is also going to hold the word part. Accumulator is also going to hold the word part. And the temporary register is also going to hold the word part. To be more precise, I'm going to show this is the main memory. In this, here we do have an address. This is the word. A word is equal to 16 digits. Total memory is divided into two parts. One is instruction and data memory. Instruction memory is going to hold all the instructions of any program, and the data memory is going to hold all the data operands of every instructions in each and every instruction within the instruction part. So one word in the main memory is equal to 16. So only in this one word, either an instruction or a data element will get stored. The word portion in the instruction memory is going to hold the instructions. The word portion in the data memory is going to hold the data elements. Obviously, instruction register, data register, accumulator, and temporary register, as it is clearly evident from our discussion, are of 16 bits in size. But both program counter and address register should only be equal to 12 digits, because one memory location will be addressed by using 12 digits. Any address size will be equal to 12 digits. So the address registers, meaning the registers which are just going to hold addresses, should be of only 12 digits. And the input register and output register should only be equal to 8 digits, because the ASCII format is just 7 digits. But there is no 7-digit register. The minimum register size will be equal to 8 digits. These are the different register and their respective sizes in the single accumulator organization. This is pretty much important to understand, because if you want to execute an instruction, that instruction must be fetched into these registers. Finally, the execution phase will happen. Okay. So in the next session, we will completely understand how instruction fetch, decode, and execution is going to happen. Thank you.